Section 11.3.19. A random sample of 40 adults with no children under the age of 18 years results in a mean daily leisure time of 5.55 hours, with a standard deviation of 2.56 hours. A random sample of 40 adults with children under the age of 18 results in a mean daily leisure time of 4.61 hours, with a standard deviation of 2.01 hours. Construct and interpret a 95% confidence interval for the mean difference in leisure time between adults with no children and adults with children, which is population mean 1 minus population mean 2. Okay, so first, what we want to do is we're going to let population 1 represent the mean leisure hours of adults with no children. So let's go ahead and highlight that. So population 1 is going to be the mean leisure hours of adults with no children under the age of 18. So that means in the first sentence there's 40 adults that have no children under the age of 18 years, has a mean time of, or a mean leisure time of 5.5 hours, and a standard deviation of 2.56 hours. And then we're going to let population mean number 2 represent the mean leisure hours of adults with children under the age of 18. So that means we have 40 adults with children under the age of 18 with a mean daily leisure time of 4.61 hours and a standard deviation of 2.01 hours. And then we're going to be able to construct our confidence interval. Now, what we're going to do in this problem is we're going to use the TI-84 calculator. Before we do that, we need to write down the given information, meaning that what is the sample mean for population 1, the sample standard deviation for population 1, and the sample size for population 1. Well, we know that the mean is 5.5 hours. We know the standard deviation is 2.56 hours. And we know that the sample size is 40. Okay, and then we need to find the sample mean for population 2, standard deviation for population 2, and the sample size for population 2. Well, we know that the mean for population 2 is 4.61. We know the standard deviation is 2.01. And we know the sample size is 40. Okay, so now what we're going to do is we're going to be able to use the TI-84 to find our confidence interval. Okay, now recall here that the difference between two population means with unknown population standard deviations approximately follows a student's t-distribution if the following assumptions are met. The samples must be simple random samples, which they are. The samples must be independent, those are 2 independent samples. And the populations must be normally distributed, or the sample sizes must be large, meaning greater than or equal to 30. Well, the sample sizes are greater than or equal to 30. So, if the confidence interval does not contain 0, then we conclude that there is sufficient evidence to reject the null. Otherwise, there is insufficient evidence to reject the null. So now we're going to use the steps for TI-84 to find the confidence interval. So let's go ahead and do that. So here we have our TI-84 calculator. Okay, and the first thing we want to do is we're going to go to Stat, and we're going to scroll to the right and see where Test is. We'll go to all the way down to where it says 0 for the 2 sample t interval, because we have unknown population standard deviations. That's why we're using the sample t interval. Let's go ahead and select Enter. Okay, now we have stats, so we don't have the data. The stats because we're given the stats. So now what we're going to do is for mean number 1, we're going to put in 5.55. And then for the standard deviation of number 1 is 2.56. Sample size is 40. The mean for number 2 is 4.61. We can see that the standard deviation is 2.01. And the sample size is 40. And now we know that the confidence level that we wanted to do that at is at 95%. So we're going to put in 0.95. And then pooled, no. And then we're going to select Calculate. Okay, so at this point here, I'm going to go ahead and copy the information that we have here. Okay, so here is our calculator screen. Okay, and so I do want to point out here that here is our confidence interval. And then we're going to round that to 2 decimal places. So the confidence interval is going to be negative 0.09 and 1.97. Okay, now I want to also make note that when you're doing this by hand using these numbers, your numbers are going to be just slightly off, but even though my math lab is going to be able to take the answers because it gives you increments of plus or minus 0.2. So here, when you're using a calculator, the degrees of freedom is 73. So this calculates a different type of degrees of freedom than you would when you're doing it by hand. So you want to pay close attention to when you see that. Okay, and now what we want to do is now we want to define what's happening with our conclusion. Okay, so let's go ahead and write our conclusion. So recall that if the confidence interval does not contain 0, you will conclude that there is sufficient evidence to reject the null, and then conclude that there is a significant difference in leisure time between adults with no children and adults with children. Otherwise, there is insufficient evidence to reject the null. So conclude that there is a significant difference in leisure time between adults with no children and adults with children. So in this case here, there is a 95% confidence that the difference of the means is in the interval because 0 is in this interval. So we would say that the 95% confidence interval population mean 1 minus population mean 2, which is 0, is the range from negative 0.09 hours to 1.97 hours.